Hi class, Happy New Year. We're going to start Unit 5. Here is the first lesson. Just quickly, system of equation is basically when you have two or more equations. So this example of system of equations has two, this example has three, and then we're going to talk about how do we solve system of equations. I'll go through the examples. And yeah, let's get started. So the first example I wanted to go over was to see how to find the solution to a system of equation by graphing. So here I have two equations and it's already graphed here. So the solution for a system of equations is where they cross each other. So let me just put a point here, this point right here. So the solution to this would be, and you have to give two numbers, you have to give the x coordinate, which is at -1, and then your y coordinate, which is at also at -1. So that's the solution right there. Here's another example. Looks like the solution is right here. This is where they cross. The x coordinate on the x-axis is at 1, and y coordinate is at -2. That's it. So this is a practice for system of equations. So I don't have a graph, but there's two ways we can remember how to graph it, using the slope and the y-intercept, or we can also use Desmos to graph and find it. Let me just go ahead and use the slope here. So it looks like the slope here is 1, and then the y-intercept b is at -8. Remember that the y-intercept is always my starting point, so it's at -8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And the slope is 1 because it's the number in the front here. That's 1. So it's up 1 over 1, up 1 over 1, and then so on. So that line right there. So the line doesn't look that great, but. And then the other one here is, looks like the slope here is -2. And the y-intercept here is at 1. So my y-intercept is at 1. So it's down 2 over 1, down 2 over 1, down 2 and over 1. Looks like it's going to cross right there. Oops, this line is messed up. Okay, so connects like that. Anyway, where do they cross? It crosses right here. So it looks like my solution is at 3 and then -1, 2, 3, 4, 5. 3 and y is -5. That's it. We can also do the same process in Desmos. Let me go ahead and graph the second problem in Desmos. So, oops. I'm just gonna plug it in. So you have y equals -5 over 3x plus 3, and then y equals 1 over 3x minus 3. And Desmos graphs it. I always like to press the home button right there, and then it crosses at 3, -2. So my solution here is +3 and then -2. The next type of questions you might see are something like this, where it says, state how many solutions each system of equation has. So we can graph it and see the type of solutions. Let me go back to the previous page. So obviously if they cross each other, you have your one solution. If they have the same slope and they're parallel lines, they have 0 solutions or no solutions. And if it ends up being the same line, then it is infinite many solutions. So the easiest way is to graph them and see. Let me just bring Desmos real quick. So I'm going to just graph it exactly the way it is. 5x plus 12 and y equals -x minus 2. And, well, there's just one solution. The number of solution here is 1. Okay, the next one, same thing. We're going to just graph it and look at what type of solutions that they have. 2x. Did you see that? It's the exact same line. Let me just ungraph. There's the first equation, there's the second equation, and it looks like it's the same line, so we can say that they are infinite solutions. Either you can just put the infinity symbol or write infinite many solutions. Okay? And then here's the last one. Let me go ahead and put this in. Y equals negative 5x, 15x, 3y equals 5. And those look like parallel lines. So if they're parallel lines, then it is number of solutions is 0 or no solutions. Okay? And then here's the last example. I graphed it in Desmos, and I'm just going to click where they cross each other. They cross at 1, 5. And with this example, since Desmos already gave the answer, I do want to show you algebraically how this solution works for this system of equation, because on the previous page I showed you that algebraically it makes both of the equations true. So how does that really work out when you have the solution right here? Well, we know that my x solution is 1, and then my y from my solution is 5. So basically, if we plug it in, so I'm going to plug it into the first equation, 2 times x, so 2 times 1 plus 4 times y, so 4 times 5 equals, does it equal 22? So 2 times 1 is 2, 4 times 5 is 20, and then 2 plus 20 is in fact 22. That works out. But it also has to work for the second equation as well. So 7 times 1, because x is 1, plus y is 5, does it equal 12? So that's 7 times 1 is 7, plus 5, does it equal 12? 7 plus 5 is 12, 12 does equal 12. So that's another way you can check your answer to see if you get a true statement. Alright? In the next video, I'm going to show you how to solve using a different method other than graphing. We're going to do it algebraically, but I'll do that in the next video. Thanks.